Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have tan x times root of secant x, right? So what we've been given is dy by dx, and we've been asked to find y. My y is nothing but antiderivative of the given expression. So I can write my y using the integral symbol. So let's write our y. So that's my y, integral of tan x times root of secant x dx. Now I know that my y is not in a very simple format whose antiderivative I know from first principles or any of the rules slash derivatives we have learned so far. Therefore, the job in hand is to simplify y. I have a tan x, I have a root of secant x, right? I know that my d by dx of secant x is nothing but a secant x tan x, right? So can I connect the secant x inside the root with the tan x outside? Yes, we can do that with a little bit of rearrangement. So the way I'm going to write this is I'll keep y aside for a minute. I'll just pick up this expression alone, which is tan x into root of secant x. And I'm going to multiply and divide by secant x, right? Now that doesn't change my expression because a secant x by secant x is nothing but a 1. So this is my expression secant x tan x into root of secant x the whole divided by secant x, right? So observe this closely. I've not done anything much. I've just divided by secant x, and to compensate for that, I've multiplied by secant x, right? Now I go back to my y. Now that's my y. Now what should immediately strike you is, can I solve this problem by the method of substitution? Why is that? Because I know that my dy dx of secant x is nothing but a secant x tan x, right? So let's do that substitution and see if we can simplify our y. So let me do t equals secant x. Therefore, my dt by dx is nothing but secant x tan x, which means my dt equals secant x tan x dx, right? I go back to my y, I go to the next line. I notice that my dt here is secant x tan x dx, right? So let me highlight this in yellow. And I do have a secant x tan x dx in my y expression as well. And then along with that, I have a root secant x by secant x, right? So I'm just doing a little bit of rearrangement, folks. So I'm just moving this secant x tan x to the other side. It doesn't change anything. Now I know that I can write my secant x tan x dx, which I see in the expression, as dt. And the substitution that I've made is nothing but t equals secant x. So I can rewrite this entire expression using t. Right? So let's write this expression using t. My root of secant x becomes root t, and then I have a secant x tan x dx, which is nothing but a dt. And I hope you folks are with me. The look at the yellow expression what we've highlighted, and then I have a divided by a secant x, right? My secant x is nothing but a t, right? Now I know that my root t by t is nothing but 1 by root t. Therefore, my y is nothing but integral of dt by root t. This is something which is quite familiar to us because I know that d by dt of root t is 1 by 2 root t, right? I repeat, d by dt of root t is 1 by 2 root t, right? So I multiply by 2 and I also divide by 2, right? So I don't change anything in the expression y, right? And what is integral of dt by 2 times root t? It is nothing but a root t, right? So I'm left with 2 times root t plus c. Now I know that I cannot leave my answer in the form of t. I'll have to put back everything in the form of x. So my answer to the problem is 2 times root of secant x plus c, right? C is my arbitrary constant. Let me highlight my final answer in pink. So there we are. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.